Emergency ascent, Wikipedia audio. An emergency ascent is an ascent to the surface by a diver in an emergency. More specifically, it refers to any of several procedures for reaching the surface in the event of an out-of-air emergency, generally while scuba diving. Emergency ascents may be broadly categorized as independent ascents, where the diver is alone and manages the ascent by him/herself, and dependent ascents, where the diver is assisted by another diver, who generally provides breathing gas, but may also provide transportation or other assistance. The extreme case of a dependent ascent is underwater rescue or recovery of an unconscious or unresponsive diver, but this is more usually referred to as diver rescue. An emergency ascent is usually used for cases where the distressed diver is at least partially able to contribute to the management of the ascent. An emergency ascent usually implies that the diver initiated the ascent voluntarily, and made the choice of the procedure. Ascents that are involuntary or get out of control unintentionally are more accurately classed as accidents. Reasons for making an emergency ascent. An emergency ascent may be made for any one of several reasons, including failure or imminent failure of the breathing gas supply. An emergency ascent implies that the dive plan has been abandoned due to circumstances beyond the control of the diver, though they may have been caused by the diver, as is often the case in out-of-gas emergencies in scuba diving. Out-of-gas emergencies are generally the most urgent contingencies in diving, as the available time to deal with the emergency can be measured in minutes or seconds, while most other non-traumatic emergencies allow more time. Other reasons for emergency ascent may include compromise of diver buoyancy control due to loss of ballast weight, loss of buoyancy or damage to buoyancy compensator, injury or illness, scuba equipment failure leading to non-catastrophic but rapid loss of breathing gas, sudden loss of thermal protection due to dry suit leak, inability to read instruments due to damage or loss of mask or severe damage to helmet faceplate, flooding of helmet or full face mask that cannot be rectified, entanglement requiring abandonment of breathing apparatus. Entrapment of bell or failure of bell recovery system, entrapment of umbilical, or damage to umbilical resulting in main gas supply failure. Few issues of diver training have been more controversial than the teaching of emergency ascent procedures. The controversy centers on techniques, psychological and physiological considerations, concern about today's legal climate, and finally the moral issue: is it wise and ethical to train divers in emergency ascent techniques, even though this training may itself be hazardous? Ronald C. Sampson and James W. Miller, 1977. Emergency ascent training policy differs considerably among the certification agencies, and has been the subject of some controversy regarding risk-benefit. In 1977, a formal policy regarding training of emergency ascent procedures was adopted by 5 major American recreational diver certification agencies: NASTS, NAI, PADI, SSI, and YMCA. Bailout ascent is where the diver makes use of a bailout set carried by him/herself to provide an emergency breathing gas supply for this kind of emergency. Blow and go is a free ascent where the diver exhales at the bottom before starting the ascent. The breath may be held during part of the ascent, as the lungs are emptied before starting. This procedure is considered unnecessarily hazardous by many recreational training agencies. Buoyant ascent is an ascent where the diver is propelled towards the surface by positive buoyancy. Controlled emergency swimming ascent is an emergency swimming ascent which remains under control and which is performed at a safe ascent rate, with continuous exhalation at a rate unlikely to cause injury to the diver by lung overexpansion. Emergency swimming ascent is a free ascent where the diver propels him/herself to the surface by swimming at either negative or approximately neutral buoyancy. Exhaling ascent is an ascent where the diver continuously exhales at a controlled rate during the ascent. This may apply to an emergency swimming ascent/free ascent or a controlled emergency swimming ascent, and distinguishes it from a blow-and-go procedure. Free ascent is the procedure used in U.S. Navy submarine escape training. However, the term is also used for other emergency diver ascent procedures where breathing gas is not available to the diver during the ascent. Open circuit bailout is a change from breathing off the rebreather loop to open circuit, either by physically changing from the rebreather dive/surface valve to an open circuit bailout demand valve, or by switching the rebreather bailout valve from closed to open circuit. This action is taken both when there is a recoverable problem with the rebreather loop, in which case once the problem has been corrected, a reversion to closed circuit is usual, or when the loop has failed irrecoverably, in which case an ascent is made on open circuit, which is generally regarded as an emergency ascent. Reserve air ascent is an ascent using a bailout cylinder or the gas in the main cylinder after actuating a reserve valve to release the gas trapped by the reserve valve. Mechanism: a reserve air ascent is not traditionally considered an emergency ascent, as it was the standard procedure before the use of submersible pressure gauges became widespread. This policy is a general agreement that emergency ascent training is worth the risk on ethical grounds, and recommends those procedures which the agencies consider most appropriate for teaching recreational divers. It does not prescribe training procedures or standards. This National Scuba Training Committee Ascent Training Agreement recognizes that there are a number of options available to the scuba diver in the event of a sudden apparent termination of breathing gas supply at depth, and that the selection of an acceptable response is dependent on several variables, including depth, visibility, distance from other divers, the nature of the underwater activity, available breath hold time, training, and current competence of the involved divers, stress levels of the divers, obstructions to a direct access to the surface, water movement, equipment, buoyancy, familiarity between divers of procedures and equipment, apparent reasons for air loss and decompression obligations. Buddy breathing ascent is where the diver is provided with breathing gas during the ascent from the same demand valve as the donor, and they breathe alternately. Octopus assisted ascent, sometimes just assisted ascent, is where the diver is provided with breathing gas during the ascent by another diver via a demand valve other than the one in use by the donor during the ascent. This may be supplied from the same or a different cylinder, and from the same or a separate first stage regulator. The diver's breathing is not constrained by each other, and they may breathe simultaneously. Terminology for emergency ascents. Recommendations for training. Recommendations for choice of procedure. No other procedures are recommended in this agreement, though the use of a bailout cylinder may be considered effectively equivalent to either octopus-assisted ascent, when gas is supplied by a donor, or not actually running out of gas if it is the diver's own bailout set. The Scottish Sub-Aqua Club holds that training is primarily to deal with potential emergencies and that it should be practical rather than purely theoretical. This implies that it is better to have some practical experience of ability to cope with a simulated emergency situation, as this gives greater insight and confidence, as well as proven ability, provided that the risk in training is appreciably smaller than the risk in not being trained. The SSAC trains open water free ascent from a maximum depth of 6-7 m, initially using a shot line to control ascent rate, and considers the risk small and the benefit significant in view of their statistics, which showed an incidence of roughly 16 free ascents per 10,000 dives. In 1978, the SSAC recommended responses to an air supply failure, in order of preference, were: the only reference to emergency ascent training in the CMAS diver training program is in the one-star course, where controlled buoyancy lift of victim to surface is specified under practical training of rescue skills. Independent action. Dependent action. Use of a bailout cylinder is the primary source of emergency breathing gas recommended by several codes of practice for scientific and commercial divers. The agreement requires scuba instructors to make students aware of the variables and how they affect the choice of an appropriate response. Training should allow divers trained by different instructors to make similar appropriate decisions under the same circumstances, and should provide divers with safe and effective emergency procedures for and out-of-air situations when not under supervision of an instructor. Divers should be taught to agree on emergency procedures before the dive when intending to dive together. Training policies of various certification agencies. NSTC Agreement, SSAC, CMAS. Commercial and scientific diving. When there is no physical or physiological constraint preventing a direct ascent to the surface, an unassisted emergency ascent may be the lowest risk option, as it eliminates the unknowns associated with finding and requesting aid from another diver. These unknowns may be minimized by training, practice, prior agreement, and adherence to suitable protocols regarding equipment, planning, dive procedures and communication. The most desirable option in the dependent category is given as the octopus-assisted ascent, where the out-of-air diver is provided breathing gas by a donor via a secondary second stage. Buddy breathing by two divers on a single second stage is specified as the least desirable of the dependent options. The recommended independent option is the emergency swimming ascent, where the diver swims to the surface at roughly neutral buoyancy, while exhaling continuously. The final option is a buoyant ascent, where buoyancy is gained by inflation of the buoyancy compensator, and dropping of weights. This is recommended as a last resort where the diver is unsure of making it to the surface by swimming, as it will ensure that an unconscious diver will rise to the surface rather than sink. An alternative emergency breathing air source may be available via the buoyancy compensator. There are two possibilities for this: making use of a companion's octopus rig, then by breathing from an ABLJ, then by a shared ascent and, as a last resort, by free ascent. Ascent where the diver is propelled towards the surface by positive buoyancy. Generally recommended as a last resort, though a sufficiently skilled diver could control ascent rate by precise dumping from the BC and use this as a low-energy alternative to a swimming ascent. In this case, weights should not be ditched during the ascent. Advantages of this method, when applicable, are that no outside assistance or special equipment is required. Disadvantages are that it requires the diver to reach the surface in a limited time, which does not allow for staged decompression, possible delays due to entanglement or snags, or long distances to reach the surface. It also requires the diver to produce propulsive effort, which reduces potential endurance on the single breath or limited gas available. Choice of procedure. Positive buoyancy may be established by inflation of the BC or dry suit, or by ditching weights. Buoyancy from added air can be controlled during ascent by dumping, but the effect of ditched weights is not reversible, and usually increases as the surface is approached. particularly if a thick wetsuit is worn. If weight can be ditched partially, this may be a better option, unless the diver feels that he is about to lose consciousness, in which case a substantial increase in buoyancy may be better. A method of buoyancy control which will automatically jettison weights if the diver loses consciousness during the ascent is to take them off and hold them in a hand while surfacing. If the diver loses consciousness, the weights will drop and positive buoyancy will take the diver the rest of the way to the surface. Controlled emergency swimming ascent is a technique used by scuba divers as an emergency procedure when a diver has run out of breathing gas in shallow water and must return to the surface. During the ascent, the diver propels him/herself towards the surface at a safe ascent rate by means of swimming, usually finning, with continuous exhalation at a rate unlikely to cause injury to the diver by lung overexpansion, and remains under control. The technique involves simply ascending at a controlled pace, typically about 18 meters per minute, while exhaling slowly. As the diver ascends, the air in the lungs expands as surrounding water pressure decreases. Exhaling allows excess volume to escape from the lungs, and by exhaling at a suitable rate the diver can continue exhaling throughout the ascent and still have air in his or her lungs at the surface. If the diver fails to exhale during the ascent, lung overexpansion injury is likely to occur. If exhalation is limited to relaxing and allowing the expanding gas to escape without effort, there should not be a feeling of running out of breath, as the air inhaled at depth expands during the ascent and the lung volume should remain nearly constant. This procedure is recommended for ascents where there is no decompression obligation, a free surface with little risk of entanglement, and the diver has sufficient breath hold capacity to easily reach the surface conscious. Use of the continuous exhalation procedure from moderately inflated lungs combines the advantages of lower risk of lung injury compared to either full or empty lungs with improved endurance due to more available oxygen. Keeping the DV in the mouth and attempting to breathe normally or slowly from it may provide additional breaths as the ambient pressure reduces, and helps ensure that the airways remain open. If the diver is neutrally buoyant at the time that the ascent is initiated, the amount of energy required to reach the surface will be minimized, and frequent controlled venting of the buoyancy compensator can keep the ascent rate under fine control. Scuba procedures. While in a practical sense there is little difference between a seiza and a free ascent, the technical difference between the two is that in a seiza the regulator second stage is retained in the mouth and the diver exhales through it, while in free ascent, the regulator is not retained or there is no regulator available, and the diver exhales directly into the water. Ascent during which the diver is provided with breathing gas from the same demand valve as the donor, and they breathe alternately. The out-of-air diver must attract the attention of a nearby diver and request to share air. If the chosen donor has sufficient gas, and is competent to share by this method, an emergency ascent may be accomplished safely. Accurate buoyancy control is still required, and the stress of controlling the ascent rate and maintaining the breathing procedure can be more than some divers can handle. There have been occurrences of uncontrolled ascent and panic, in some cases with fatal consequences to both divers. This procedure is best suited to divers who are well acquainted with each other, well practiced in the procedure, and highly competent in buoyancy control and ascent rate control. Walker, D. Emergency Ascents, Some Background Information. South Pacific Underwater Medicine Society Journal. 8. ISSN 0813-1988. OCLC 169868801. Retrieved 2008-08-07, Knight, J. Free Ascent Training. South Pacific Underwater Medicine Society Journal. 8. ISSN 0813-1988. OCLC 16986801. Retrieved 2008-08-07, Egstrom, G.H. Ascents. South Pacific Underwater Medicine Society Journal. 8. ISSN 0813-1988. OCLC 16986801. Retrieved 2008-08-07, Curtis, ASG. Free Ascents, A View from the Scottish Sub-Aqua Club. South Pacific Underwater Medicine Society Journal. 8. ISSN 0813-1988. OCLC 16986801. Retrieved 2008-08-07, Graver, D.K. In support of emergency ascent training. South Pacific Underwater Medicine Society Journal. 8. ISSN 0813-1988. OCLC 16986801. Retrieved August 7, 2008. Ascent while breathing from the buoyancy compensator. Ascent during which the diver is provided with breathing gas by another diver via a demand valve other than the one in use by the donor during the ascent. This may be supplied from the same or a different cylinder, and from the same or a separate first stage regulator. The diver's breathing pattern is not constrained by each other, and they may breathe simultaneously. Buoyant ascent. Controlled emergency swimming ascent. Buddy breathing ascent. An ascent where the diver is pulled to the surface by the line tender, either as a response to an emergency signal from the diver, or a failure to respond to signals from the surface. A diver may also be assisted in the ascent by the line tender in a normal ascent, particularly divers in standard dress, where it was often the normal operating procedure. The controlled buoyant lift is an underwater diver rescue technique used by scuba divers to safely raise an incapacitated diver to the surface from depth. It is the primary technique for rescuing an unconscious diver from the bottom. It can also be used where the distressed diver has lost or damaged his or her diving mask and cannot safely ascend without help, though in this case the assisted diver would normally be able to control their own buoyancy. The standard PADI train technique is for the rescuer to approach the face-down unconscious diver from above and kneel with one knee either side of his or her diving cylinder. Then, with the victim's diving regulator held in place, the tank is gripped firmly between the knees and the rescuer's buoyancy compensator is used to control a slow ascent to the surface. In the technique taught by BSAC and other agencies, the rescuer faces the casualty and uses the casualty's buoyancy compensator to provide buoyancy for both divers as the rescuer makes a controlled ascent. If the casualty is not breathing, the ascent will be urgent. If the two divers separate during the ascent, the use of the casualty's buoyancy is intended as a fail-safe, causing the casualty to continue to the surface where there is air and other rescuers can help. The diver opens the bailout valve on the helmet, band mask, or harness-mounted bailout block. This opens the supply of breathing gas from the bailout cylinder carried by the diver to the demand valve of the breathing apparatus. The bailout gas volume carried by the diver is usually required to be sufficient to return to a place of safety where more gas is available, such as the surface, diving stage, or wet or dry bell. Another option for the surface-supplied diver is to breathe air supplied through the pneumofathometer hose of the umbilical. The diver inserts the hose into the air space of the helmet of full face mask, and the panel operator opens the supply valve sufficiently to provide enough air to breathe on free flow. Pneumo air can be supplied to another diver by a rescuer in the surface supply equivalent of octopus air sharing. This procedure would save the bailout gas, which would then be available if the situation deteriorates further. Pneumo breathing air supply is not applicable to environmentally sealed suits for contaminated environments. In the event that a wet bell or stage cannot be recovered from a dive on schedule, it may be necessary for the divers to abandon it and make an autonomous ascent. This may be complicated by decompression obligations or compromised breathing gas supply, and may involve the assistance of a surface standby diver. The procedure depends on whether the diver's breathing gas is supplied directly from the surface or is supplied from a gas panel in the bell, via the bell umbilical. To abandon a Type 1 wet bell or stage, the divers simply exit the bell on the side that the umbilicals enter, ensuring that they are not looped around anything. This is reliably done by having the surface tender take up slack while returning to the bell and following the umbilical out the other side, after which the tender can simply raise the diver as if there were no bell. On a Type 2 bell, the umbilicals are connected to the gas panel in the bell, and the procedure used should minimize the risk of the umbilical snagging during the ascent and forcing the diver to descend again to free it. The most direct and well-publicized hazard is lung overpressure due to either a failure on the part of the diver to allow the expanding air in the lungs to escape harmlessly, or entrapment of air due to circumstances beyond the control of the diver. Lung overpressure can lead to fatal or disabling injury, and can occur during training exercises, even when reasonable precautions have been taken. There is some evidence that a full exhalation at the start of the ascent in the blow-and-go scenario can lead to partial collapse of some of the smaller air passages, and that these can then trap air during the ascent sufficiently to cause tissue rupture and air embolism. The procedure of slowly letting the air escape during ascent can also be taken too far, and not allow the air to escape fast enough, with similar consequences. Attempting to breathe off the empty cylinder is one way of potentially avoiding these problems, as this has the double advantage of keeping the airways open more reliably, and in most cases allowing the diver several more breaths during the ascent, as the reduced ambient pressure allows more of the residual cylinder air to pass through the regulator and become available to the diver. A 10-liter cylinder ascending 10 meters will produce an extra 10 liters of free air. At a tidal volume of about 1 liter, this would give several breaths during ascent, with increased effectiveness near the surface. Of course, this air is not available in some cases, such as a rolled-off cylinder valve, burst hose, blown O-ring, or lost second stage, where the failure is not simply breathing all the air down to the pressure where the regulator stops delivering, but if it is possible, the demand valve can be kept in the mouth and the diver can continue to attempt to breathe from it during a free ascent. One of the dangers of a free ascent is hypoxia due to using up the available oxygen during the ascent. This can be aggravated if the diver fully exhales at the start of the ascent in the blow-and-go technique, if the diver is so heavy that swimming upwards requires strong exertion, or if the diver is already stressed and short of breath when the air supply is lost. Loss of consciousness during ascent is likely to lead to drowning, particularly if the unconscious diver is negatively buoyant at that point and sinks. On the other hand, a fit diver leaving the bottom with a moderate lungful of air, relatively unstressed, and not overexerted, will usually have sufficient oxygen available to reach the surface conscious by direct swimming ascent with constant exhalation at a reasonable rate of between 9 and 18 meters per minute from recreational diving depths, provided his or her buoyancy is close to neutral at the bottom. The risk of decompression sickness during an emergency ascent is probably no greater than the risk during a normal ascent at the same ascent rate after the same dive profile. In effect, the same ascent rate and decompression profile should be applied in an emergency ascent as in a normal ascent, and if there is a decompression requirement in the planned dive, steps should be taken to mitigate the risk if having to make an ascent without stops. The most straightforward and obviously effective method is for the diver to carry a bailout set sufficient to allow the planned ascent profile if the primary gas supply fails. This makes each diver independent on the availability of air from a buddy, but may cause extra task loading and physical loading of the diver due to the extra equipment needed. This method is extensively used by commercial and scientific divers, solo recreational divers, and some technical and recreational divers who prefer self-reliance. When all else fails, the consequences of missing some decompression time are usually less severe than drowning. Drowning is the most likely consequence of a failure to reach the surface during an independent emergency ascent, and is a significant risk even if the diver reaches the surface if he or she loses consciousness on the way. These documents are of historical interest, as representing the attitudes regarding the training of emergency ascents circa 1978. Octopus-assisted ascent, lifeline-assisted ascent, controlled buoyant lift, surface-supplied procedures, ascent on bailout gas, ascent on pneumo air, bell or stage abandonment, hazards, lung overpressure accidents, loss of consciousness due to hypoxia, decompression sickness, drowning, mitigation of hazards. Additional reading.